Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Goupale. So basically in today's video, we are going to discuss the implementation of positive edge trigger deep flip-flop by using 2:1 multiplexer and negative edge trigger deep flip-flop by using 2:1 multiplexer. So let's get started with positive edge trigger deep flip-flop. It has two inputs, D and clock, and two outputs, that is Q and Q bar. I talk about functionality. So if there is passage, then the flip-flop samples the value at the input and transfers that value to the output Q. And if there is no edge, that means if there is an egg edge, then it will ignore the input value to input value T and it will hold the current value at the Q output. Again, the main advantage of flip-flop is that the data is stable for one clock cycle. Even we can design flip-flop by using two latches in cascade. So if I talk about positive edge triggered flip-flop, so we can design positive edge triggered flip-flop by connecting negative level sensitivity latch with positive level sensitivity latch in cascade. Here you can see the input D is given to the negative level sensitivity latch. Now the output of this negative level sensitivity latch is going as an input to this positive level sensitivity latch. The output of this positive level sensitivity latch will act as a D flip-flop. Okay. If you know, in my previous video or one of the video of positive and negative level sensitivity latch by using 2:1 multiplexer, I have explained you very well how we can implement positive level sensitivity latch by using 2:1 multiplexer and negative level sensitivity latch by using 2:1 multiplexer. Before watching this video, go and watch that video, because here we are going to design positive edge trigger flip-flop by connecting two latches in cascade, that is negative level sensitivity latch with positive level sensitivity latch. So if we connect implementation of negative level sensitivity latch by using 2:1 multiplexer with positive level sensitivity latch by using 2:1 multiplexer in cascade, then this will form the positive edge triggered deep flip-flop by using 2:1 multiplexer, or I can say this is how we can implement positive edge triggered deep flip-flop by using 2:1 multiplexer. Here you can see this is the implementation of negative level sensitivity latch by using 2:1 multiplexer, and this is the implementation of positive level sensitivity latch by using 2:1 multiplexer. So now if we talk about functionality, so when clock is high, so due to this negation for this multiplexer, my select line will become 0. If clock is 1, for this multiplexer select line becomes 0. So due to the select line, this input D will be sampled or will route it to the output Q1, and this Q1 output is input for this second mux, and right now my clock is high, so this Q1 will be routed to the output Q. So if my D is high here, so output is also high. Now when the negation is there, when clock is 0, okay, so due to this negation for the select line, my select line will become high. So as if select line is high, so as per the functionality of deep flip-flop, if there is an egg edge, means if there is an egg edge, then it will hold the current value of Q. So this will hold the current value of Q. Okay. Now again, where clock is 0, so my current value of Q is high. So in output also what I will get, high only on this negation. Again, if there is passage, so for this select line, my D will be routed to the output Q1. Okay, this Q1 is input for this mux. So due to this select line high for this mux, my Q1 will be routed to the output Q. So on this passage also, when my D is high, so output is also high. Now at this negation, you can see my D goes low, but output is still high, because when clock is 0, so from this mux, it is holding current value of Q, and current value of Q1 is high only. Even from this mux also, due to the select line 0, my current value of Q is high. So you can see for this negation also, my Q is high itself. That means it is giving output as per the D flip-flop only. Okay. This is the real-time waveform of the positive edge triggered D flip-flop. This is the clock when at this passage when D is high, so output is high. At this negative, you can see my D goes high, but still my Q is high because functionality says that if there is a negative, then it will hold the current value of. Okay, so this is how we can implement positive edge triggered D flip-flop by using 2:1 multiplexer in cascade. Okay, now if I talk about negative edge triggered D flip-flop, so it has also two inputs, D clock and output Q. If we talk about functionality, so if there is a negate, then only the D flip-flop samples the value at the D input and transfers that value to the output Q. And if there is a no negate, that means if there is a passage, then it will ignore the input value D and it will hold the current value of Q out. Okay. Similar like positive edge triggered D flip-flop, even we can design a negative edge triggered D flip-flop by using positive level sensitivity latch with negative level sensitivity latch in cascade. Okay, but when it comes to the implementation of negative edge triggered D flip-flop by using 2:1 multiplexer, so we can connect a positive level sensitive D latch by using 2:1 multiplexer with another positive level sensitive D latch by using 2:1 multiplexer. Then this implementation will acting as a negative edge triggered D flip-flop. Okay, so let's understand the functionality of this connecting positive level sensitivity latch by using 2:1 mux, as this is acting as a negative edge triggered D flip-flop. So when clock is at the passage, so when clock is high, so for this mux select line is 1. Okay, so D will be routed to the output Q1. Okay, now Q has hold the value of D, whatever it is, although it is high or low, Q has holding the input value D, but we are getting output for negative edge trigger D flip-flop from this output Q. So when clock is high, so due to this negation for this mux, my select line is 0. So it has hold the previous value. Now whatever the previous value, although it is high or low, we'll get that value. So here you can see for at this passage D is routed to the Q1, but my Q is still low only because it has hold the previous value. Now when my clock is low, so Q1 is holding the previous value because select line is 0 and my previous value of Q1 was what? D, and D was what? High. So it has hold the D value. Now this Q1 output of this first mux is going as input for this second mux. Okay, so and due to this negation, when my clock is 0, so for this mux my select line becomes high. So this Q1 will route it to the output Q. So at this negate, you can see this D is reflecting here. Q goes high. Okay, now again if I talk about this passage, so again my clock is high. Okay, clock is high, so for this mux select line is 1. Okay, so D will be routed to the output Q1. Okay, and as due to this negation for this select line, this Q will hold the previous value, and previous value was what? High. So here you can see at this passage my Q is high only. Okay, now again when clock is 0, so whatever the Q1 value, here you can see D value goes low, so Q1 has the D value as a low, so Q1 has value low. Now Q1 is routed to this mux. Okay, as due to negation my select line becomes 1, and now Q1 will be routed to the output Q. So here you can see at this negate Q1 is routed to the Q. So this is how the negative edge triggered D flip-flop by using 2:1 multiplexer is working here. So in this video we have discussed positive edge triggered D flip-flop by using 2:1 multiplexer and the implementation of negative edge triggered D flip-flop by using 2:1 multiplexer. For the implementation of these deep flip-flops, positive and negative deep flip-flops, we have uses the latches, that is positive edge trigger latches and negative edge trigger latches in a cascaded. Okay, so I'll stop here. If you are new to this YouTube channel, then please subscribe to my YouTube channel. And if you are watching this video, then please click on the like button. Thank you so much.